Integer exponents. So, exponents are repeated multiplication. 5 to the third equals 125. So when we talk about powers of 5, so what we just said, 5 to the third is 125, which we got from 5 times 5 times 5 times 5. 5 times 5 times 5. Sorry, 3 copies of 5. 5 squared is 5 times 5, which is 25. 5 to the first is 5. When we're continuing up, by increasing the power of 5, we'd multiply by 5 again. And we multiply by 5 again to get to 625. That's how we continue this. Well, which way? How do we go backwards? We were multiplying by 5 to go up in higher powers. Well, the opposite of multiplying by 5 is to divide by 5. So if we repeatedly divide by 5, then what happens is we do 25 divided by 5 is 5, and 5 divided by 5 is 1. So that's the natural continuation, that if we continue dividing by 5, we'll get to 5 to the 0th equals 1. If we keep going, 5 to the negative first is going to be 1/5, and 5 to the negative second, we will divide by 5 again and get 1 over 25, 1/25. So these are our powers of 5 if you follow the pattern with higher exponents that's multiplying, so smaller exponents need to be dividing. So this pattern continues. It's not specific to 5s. If we have powers of 2, as they go up, we're multiplying by 2. Anytime we're going down, we're dividing by 2. Going up in powers of 3, we're multiplying by 3, and down, we're dividing by 3. Up in x, well, x to the first is x squared, x cubed, x to the fourth. If we divide, we get down to 1, and then 1 over x squared. You will note that for all of these, whatever number it is to the 0th power gives you 1. No matter what, any real number except for 0 to the 0th power is 1. And once we start putting negative exponents, it is division. So that's how we apply this. 11 to the third is 11 times 11 times 11, which is 1,331. So 11 to the negative third is 1 divided by 11 to the third, or 1 divided by 1,331. And anything to the 0th power is not 0. It's very tempting to say it's 0. It's 1. So here's some word problem practice, not intense word problems, but f of 0.4. If this is negative to the negative first power. So what we need to do is we need to write this as a fraction so that we can take the reciprocal of it. So 0.4 is 4/10 to the negative first, or 2/5 to the negative first power. So when we take that to the negative first power, we're dividing and we get 5/2. Write y in terms of a. So this is a over y squared equals 25. That's what the negative exponent does. It tells us to put it in the denominator. So we're trying to get y by itself, so I'll multiply by y squared on both sides. A equals 25y squared. Now we have 25y squared. We want to divide by 25 to get y by itself. A over 25 equals y squared. And now when we take the square root of both sides, we get y equals square root of a over 5. If you want to be picky, you'll say plus or minus square root of a over 5. But I won't worry about that if I were you right now. So please note that if we see negative exponents, well, what this is saying is that this is a to the negative m over b to the negative n. Well, this is 1 over a to the m, and this is 1 over b to the n. So if we write that out as the division it is, you see this as that. Well, our multiplication, our dividing fraction rules say that what we typically will do is multiply by the reciprocal of the second fraction, and then when we multiply fractions, we multiply across, getting b to the n over a to the m. Now, why does this matter? Well, look at the beginning and the end. There's a shortcut to go from here to here. What you see is that the two terms switch places, the numerator and denominator switch places, and the exponents are now positive. So, if a negative exponent is in a numerator, you can make the exponent positive and place it in the denominator, or vice versa. So, this is an easy trick to remember. If you want to do it out the long way every time, you can, but this is the fast way. So, how do we simplify this? I'm not going to simplify it all the way, but this is the same thing as 3 to the 5th over 5 to the 3rd. Here, this is the only negative exponent, so it's going to end up in the numerator. When there's nothing in the denominator, it's just 1. So this is how we would write it. Here, this is 4 to the negative 4th over 2 to the 4th. Well, this is going to be in the denominator now, and when there's nothing in the numerator, that's a 1. 2 to the 4th times 4 to the 4th. Here, both of these are negative, so it will become a cubed over t squared. Here, this is the only thing that's negative. The negative does not apply to the z because they're not in parentheses together. So this is z over x squared y to the 5th. And here, this is a negative exponent, so it'll go in the denominator. P cubed y squared. And please note that x to the 0th, that is 1. Anything to the 0th power is 1. We already learned that. So, if this is 50, what is y in terms of x? Well, this is x over y equals 50. We can cross multiply here and get x equals 50y, divide by 50, and get y equals x over 50. Here, what is v cubed? Well, v to the negative second power is 1 over v squared, and that's 1 over 16. If we cross multiply by here, we'll get 16 equals v squared. So v equals plus or minus 4. And then when we're trying to find v cubed, we can say v to the 3rd power will be the plus or minus 4 cubed, which will be plus or minus 4 times 4 is 64, times 4 is not 128, but 256. No. 4 times 64. 4 times 4 is 16. Times 4 is 24. 4 times, 64. There we go. Please note, it's very tempting to try to say that this is 1 over m plus n. It's not. This is 1 over m plus 1 over n, which is not the same thing. Order of operations says you have to do the exponents before you do the addition. Thanks.